Okay, what I'm going to try to do is show you how to work through Quiz 3. Several people had questions about it. Some people had problems with it. So basically every time we do a problem, I always start with the schematic. So this one is generally laid out as one series resistor into a parallel pair, another series resistor. Hopefully you all understand why I'm calling them series or parallel. We've got 3 resistors in parallel, and they're all hooked to a 25 volt source. R1 here is 1K. We've got a 500 and a 400 in parallel. We have this goofy number, and you got to understand that when people write textbooks, they like things to come out evenly. So I took this from another textbook, so guess what? That probably means that that will work out to be something even. When I make up the exam, you can expect that not to be the case, so we'll end up with some goofy numbers. But in general, I like to take things that other people have already worked through the problems with. So we've got the basic circuit. As such, we know that there are a couple of things that will be converted into equivalents. So when I take the circuit and simplify that parallel pair, that is actually going to be 500 times 400 divided by 500 plus 400, or you can use the other methods of solving 2 resistors in parallel. This is R1, R2 over R1 plus R2. We could go 1 over the quantity 1 over 500 plus 1 over 400. You end up getting the same answer, or you should. And what I got out of that was 222.2 ohms. And then again, looking at that number compared to this one, we got 222.2. That should tell you something, because we've got 777.8. Guess what? When you add these two together, because they're in series, they give you 1K. Let me get that back in here. So 1K. So that's kind of convenient, and that's kind of what I expected to happen with this circuit. Looking at this one, we've got a 2K in parallel with a 2K, and solving those one at a time, I know that 2 resistors of the same value in parallel will give you one, or an equivalent of half that. So this is 2K in parallel with 2K gives me 1K. That's in parallel with another 1K. So that means that will give me a 500 ohm equivalent resistance. So we've got a 1K in series with a 1K from these 2 resistors in series with 500 ohm. So RT then is going to be the 1K plus 500, or 2.5K. If you had a problem with that, then odds are all of your answers will be wrong. That's one of the problems with giving an assignment or a quiz all based on the same circuit, is that we always use the information to answer from one question to answer the other question. So taking that information, that's the answer to question 1. Question 2 is, what is the total current? So IT is equal to the voltage total divided by the resistance total, so that's 25 volts divided by 2.5 K, and that gives me 10 milliamps. Question 3 is, what is the voltage across resistor 1? That's this guy up here. When you're working the quiz, you'd have that diagram in front of you so you could see that. I can say that, well, R1 times the current has got to be the same through all those series elements, so R1 times 10 milliamps will give me the voltage across resistor 1, so that I could say that's I1 R1, which is 10 milliamps times 1K, so that is 10 volts, Or I could say, using the voltage divider rule, that is 1K divided by 2.5K times the voltage across the whole thing, so 25, still gives you 10 volts. Either of those would work, and again, they all kind of depend on that 2.5K, so it's unfortunate that if you got that one wrong, you were pretty much lost. Okay, so question 4 was, what is voltage 2? So V2 would be the voltage across R2. This voltage then is going to be given by the voltage divider rule. So V2 is equal to, looking at the series circuit here, 222.2 divided by 2.5K times 25 volts, and that gives me 2.22 volts. Could use the same thing here with current, so it would be 10 milliamps times 222.2 ohms, gives me still 2.22 volts. So we've got a very small voltage there. Question 5, what is V4? Voltage 4 would be the voltage across this resistor. This is R4, the 777.8, and so sure enough, 777.8, so that I4 R4 is equal to 10 milliamps times 777.8, which gives me 7.78 volts. Again, since we know the voltage across the 1K will give me 10 volts, like we figured out up here, this is essentially a 1K resistance. Then we have 10 volts across this pair, so the two of these should add up to 10, and sure enough, 7.78 plus 2.22 adds up to 10 volts. So the last question, number 6, is what is V6? V6 is one of these down here. So let's see, that's 4, 5. So this is R6. So it's the 2K. So it's the same voltage across the 2K as it across any one of these. So R5, 6, and 7 are all the same. So that's 500 ohms divided by 2K, or 2.5K times 25 volts. And so that gives me 5 volts. And so that's the answer to the last part. Again, unfortunately, if you get the first part wrong, the rest of them are going to fall apart as well. If you did get that, then I'll try to take a look at the quiz papers. Unfortunately, when I don't see the work, I can't give you partial credit because of the way you calculate it. All you're doing is putting in an answer. So that kind of fell apart. But if you got it wrong, that's what the problem was.